Hello. This video lecture will cover the second part of section 5.4, factoring by grouping and special forms. The objective in this video lecture is to factor polynomials by grouping terms. So let's get started. Our first example asks us to bring out a common binomial factor. So in this case, what I want to do is I want to separate everything by the addition sign. So in this case, I have the first term, 2y times y minus 4, and I have the second term, 5 times y minus 4. Remember, things in parentheses are grouped together. So in this first case, I could say that this is 2 times y minus 4. And in the second case, I can write this as 5 times y minus 4. So you can see, based on the previous video lecture, the only thing that these two share is this term y minus 4. So we want to factor this term out of the equation. So we want to write this as y minus 4 times whatever's left over. The leftover in this case is 2y from the first term, and this is where that addition sign comes in. So we want to have 2y plus the remaining part from the second term, or 5. So factoring out the binomial factor in this case leaves us with an answer of y minus 4 times 2y plus 5. Our second example here talks about factoring by grouping. This method is typically used when you have 4 terms. In this case, the first thing that I notice is that this polynomial is not written in standard form. So I'm going to go ahead and do that now. We have 4x to the 4th minus 2x to the 3rd minus 6x plus 3. Now, this method asks us to look at just the last two pieces, and we try to find the greatest common factor among them. In this case, since the leading coefficient is negative, I would probably pull out a negative term. So here I would pull out a negative 3, the greatest common factor of negative 6x and positive 3. By pulling out a negative 3, that's going to leave me with 2x from the first term, because negative 6 is given as negative 3 times 2, and then we need the x on the inside. Negative 3 times negative 1 is going to give me the positive 3 that I need for the remainder. So what I've done is I've taken the negative 6x and I've written it as negative 1 times 2 times 3 times x. And I've written the positive 3 as negative 1 and negative 1 and 3. Now the reason I've included a double negative here is because I need at least one negative 1 and a positive 3. That's what allows me to pull out this negative 3. The remainder then is 2x, which is where this 2x comes from, and the negative 1, which is where that negative 1 comes from. Now this is where the method gets a little bit tricky. This 2x minus 1 in the back has to be copied to the front. So we have 2x minus 1 in the front here as well. This kind of goes to what we've done previously with a common binomial factor. So then I'm going to write the first two terms, and I'm going to take out a 2x minus 1. So the first term I'm going to write as 2 times 2 times x times x times x times x. And the second term, the negative 2, I'm going to write as negative 1 times 2 times x times x times x. Now this is where this method is a little bit different, because now I know that I need to pull 2x minus 1 out. So from the first one I'm going to pull out a 2 and an x, and from the bottom one I'm just going to pull out a negative 1. What this shows me is that the leftover is going to be 2 times x, both on top and on bottom. These two have to match. So the term that's going to go out front here is going to be a 2 times x to the third. And so now I have all the parts for my final answer. My final answer is going to be 2 times x to the third minus 3 times 2x minus 1. You can see the 2x minus 1 from both pieces gets factored out, and then the remainder is the 2x minus 3. So this is my final answer. And that concludes part 2 of section 5.4, factoring by grouping.